construction of a new locomotive is in the design, and here on the drawing board the designing engineers thrash out the wheel arrangement, the boiler size, and the weight which will be permitted on each pair of wheels, all of which have to be correlated to the tractive effort or hauling power of a locomotive. These engineers must decide on the type and quality of material to be used in the building of the locomotive, and when a tentative outline of the main points of the design have been agreed upon, then they will direct the 1001 drawings of details of parts which go to the making up of a complete set of working drawings. These draftsmen are making the various working drawings, and when these drawings are completed, they are then traced on wax linen or tracing cloth, and together with the numerous calculations of strength of working parts which have to be taken out, are filed for future reference. From the drawings, lists of materials required in the manufacture of the different parts are made out, so that orders for exact quantities and of the correct quality may be placed with the rolling mills and other sources of raw material supply. From the rolling mills will come the plates for the making of the boilers, pig iron from the blast furnaces, coke and coal from the mines, copper, tin and lead from the smelters, as well as an infinite variety of raw materials of other classes. The tabulation, storing and custody of these until each is required for fabrication in the workshops is quite a job of work in itself and calls for a high degree of organization and accounting. Before material is accepted for use in the building of a locomotive, it is required to undergo certain specified tests, so that apart from any economic consideration, the safety of the railway's patrons, the travelling public, must be fully guarded. In this laboratory machine, pieces of metal are pulled apart to determine the ultimate strength of the metal before it will actually give way or break. The part he is pointing to is the part which is being pulled apart. In this other machine, material is being tested with regard to its ability to stand up to shock, or as it is known, to impact loading. Chemical analyses are made to ensure that deleterious substances are not contained in any of the materials of construction. This is a most important phase of material control. Microscopic examinations are also made, and X-ray pictures are taken so that no parts may remain hidden to the constructing engineer. Before the actual work of building commences, the numerous operations are planned so that each part may be ready on the correct dates and the work proceed in an uninterrupted manner. Without this planning, each different section engaged on the work would be claiming a preference for itself in the order in which the work would be done. For the production of castings in steel, cast iron or non-ferrous metals, patterns have first to be made, and here craftsmen of a highly skilled trade are engaged in making a wooden pattern of the part to be moulded and cast. In the making of these patterns, the craftsman must provide in his measurements an amount to allow for shrinkage of the metal after it has been cast in a molten state and then cooled and contracted. he must provide patterns or core boxes even for the holes in a casting. Otherwise, we would not have the many intricate shapes required, but a solid lump of metal. In the foundry, machine moulding plays a very large part, particularly where repetition work is concerned. Here is what is known as a jolt roll-over machine. You see the machine rolling over, and the pattern is withdrawn from the mould on the return roll. The pattern having been withdrawn leaves the top portion of the mould ready for placing on the bottom portion, and later molten metal will be poured in and a casting will be made. When a floor mould is being prepared, the moulder beds the pattern in a specially prepared moulding sand, which, when properly consolidated, a technique of the moulding trade, will allow the pattern to be withdrawn and retain the shape of the pattern. The mould will also be strong enough to stand up to the pressure of the molten metal being poured into it, but will not be so closely compacted as to prevent gases generated during the pouring process leaking rapidly away, an alternative to which would be the bursting of the moulds. The pattern to be withdrawn is wrapped and then lifted out of the mould. Here you will recognize the familiar shape of a smoke box door for a locomotive. After lifting the pattern out of the mould is dusted with flour, and the top box turned over and then replaced on the bottom mould. Here the top portion of the box is being lowered onto its bottom portion. After this lowering, the mould is weighted in order that the molten metal, when poured into the mould, will not float the top box off. The top box, although heavy in itself, will quite easily float off on the molten metal, unless the necessity of the heavy weights being placed on the completed mould is taken care of. On the completion of moulding, the furnace or cupola in which the iron is melted is tapped, and the molten metal from this cupola flows into a large ladle, which is then taken round the shop for the purpose of filling smaller ladles. In this instance, the large ladle is used for pouring directly into the mould, as the casting is rather a large one. It is a long cry from the village smithy to this modern smith shop, and although there is no roar of bellows, there are still the sparks to gladden the small boy's heart. The modern boy in this smithy would enjoy a greater pyrotechnic display than would the children of Longfellow's poem. This scene shows a butt welding machine in operation. Here we have two pieces of metal clamped between the jaws of the machine, and an electric current is being passed through them. You will notice a white spot in the center of the picture. That is the steel being heated to a welding temperature. Now watch the sparks fly. There they go. These are the things that gladden the small boy's heart. There you see the bar which has been welded. It is released, again clamped in an accessible position, and the excess material is cut off. Having completed the welding process, the bar is now placed under a steam hammer for swaging or rounding up. The rounding up or swaging doesn't take very long, and welding a bar such as this, which is 2.5 inches in diameter, has occupied about 3 minutes. Drop hammers quickly form, nearly but not quite, molten pieces of metal into the desired shapes, and by eliminating the lengthy process of anvil forging, reduce the cost of these parts. However, only where large numbers of similar articles are required is this method of smithing justified. After the article has been drop forged, it is removed from the dies and is then placed in a finning machine where the excess metal is removed. Powerful steam hammers pound and form the heavy forgings. There are no smith's fires here, but forging furnaces are necessary in their stead to take care of the heating of the large material. The drivers of these hammers become so expert in regulating the blow that they often claim they can gently press a cork into a bottle without any damage. Another form of forging is by means of this hydraulic forging press, and this forging gang is engaged in making a locomotive axle from a steel bloom. This machine can exert a pressure of 600 tons at each stroke, and you can see what it does to the material being forged. On finishing operations, the press operates at about 1 stroke per second. Sound teamwork is essential with this gang, as any errors are impossible to rectify after a 600-ton squeeze has done its part. The man on the left is the forger, and the 3 men on those huge tongs are his assistants. Here is shown an axle as it comes from the forging press, and underneath it is the bloom from which 2 such axles can be forged. Flat plates, which have been cut to correct size and drilled, are now being rolled to the familiar shape of a boiler. This particular plate will form part of a firebox for a boiler, and you can see it taking that shape as the rolling process proceeds. All parts, of course, cannot be rolled. Some plates, to meet requirements, must be flanged. And here, in this 150-ton hydraulic press, is a plate which is being formed or flanged, and which will later form what is known as the throat plate of a locomotive boiler. Actually, 2 plates are being formed in this one operation. There is the plate being squeezed up round the die, and the men are now putting on the clamps in order to pull the plate away from the piercing die. Today, much time and labour is saved by the comparatively modern practice of oxyacetylene or electric welding. And here is the operation of welding a copper plate in the firebox of a locomotive boiler. This process is oxy welding, not electric. this machine, the tubes which are fitted into a boiler are being electrically butt welded. After all the plates have been rolled and formed, they are fitted together in the form of a boiler and bolted. Later, it will be riveted and mounted. After the boiler has been completed, it is sent to the testing pit where it is tested, first by hydraulic pressure to 50% over its ordinary working pressure, and then later it is steamed with a 10% greater pressure than it would ordinarily be called upon to carry. This latter pressure is held for not less than half an hour, and after the boiler has cooled following this test, a further test is then given, and if everything is satisfactory, the boiler, after thorough internal cleaning, is ready for use in a locomotive. Here is a small section of the machine shop with its many and varied types of machines. On these tables or slabs, parts are carefully lined and marked out so that the machinist will not have any difficulty in setting up his tools to correctly carry out the cutting and shaping. This marking off section, as it is known, works strictly to the drawings supplied by the designer, and no divergence from these drawings is permitted. Here is a horizontal boring machine carrying out boring operations on a locomotive cylinder liner. This is a vertical borer in which engine axle boxes are being brought to their correct sizes. Lathes are one of the oldest types of machine tools and predominate in any large engineering works where countless turning operations are required. Planing machines have their own particular function. This machine is planing a bogie girder casting. The milling machine has its combination of tool settings to allow the various shapes to be produced. Slotting machines are more or less vertical adaptations of shaping machines, but are usually reserved for work on the heavier class of job. Combination turret lathes are in use where large numbers of smaller articles are turned out. Note the various tools on the turret head ready for each succeeding operation. This grinding machine is for the purpose of obtaining a fine finish on a flat surface. Here is another type of grinder, known as a cylindrical grinder. It is screwing up the piston rod of a locomotive. Large lathes are used for the turning of wheel tires, and very heavy cuts are taken. That important safety device, the Westinghouse brake gear, receives thorough checking before it is permitted to be used, and here are a number of Westinghouse air pumps undergoing their test runs before dispatch to the assembly or erecting shop. When all the various parts that go to make up a complete locomotive, that is, castings from the foundry, Forged components from the smithy, the boiler and Westinghouse brake gear are well progressed. The work of assembly starts. The frames are set in position and lined up. A saddle is then fitted, and here is a saddle being lowered into position between the frames. After the saddle and cylinders have been fitted to the frames, and other numerous parts in accordance with the exact requirements laid down in the design are also fitted, some of the superstructure, such as the cab, which you will see on the left of the picture, has been secured in position. Here you will see the boiler being lowered into the frame. In another part of the shop, the engine wheels have been set out, and the men are preparing the side rods for fitting to the wheels. These wheels are now ready for the boiler and frame portion to be lowered onto them. And you can see the frame coming into view as the boiler and frame are slowly and accurately lowered onto the wheels and axle boxes. After the engine is wheeled, the whole thing complete is then picked up by powerful overhead cranes and is carried down the shop to the weighing pit, where the load on each pair of wheels will be adjusted by another gang. The engine having arrived at the weighing pits, these men are determining the weight on each pair of wheels by means of steelyards or weighing machines. If you look closely, you will notice the steelyards as the men operate them.